So today we're going to take all of those words that we learned on Friday, same side exterior, alternate interior, corresponding, and we're going to write some theorems about them. I'm not going to tell you the theorems, we're going to discover the theorems. To discover the theorems, first we need to learn a new construction with our straight edge and our compass. So I want everyone to take out a plain sheet of paper and first draw a line on your paper. Alright, so we've got a sheet of paper out, we're using our straight edge, and we're drawing a line. It doesn't need to be horizontal. It can just be any line on the paper. We're going to draw a line. What we're going to construct is you're going to learn how with a compass to construct parallel lines, because this unit is called parallel and perpendicular, and you've already learned how to construct a perpendicular bisector. You've never constructed parallel lines. Remember, that doesn't mean draw parallel lines on graph paper. It means construct them with a compass. So what we're going to do here is put a dot on the line, anywhere on the line, a point. And then wherever we want our new parallel line to lie, we're going to put a point above our line anywhere we want. So these points are what we call arbitrary. It doesn't matter where you put them, but we're pretending that you're given the line and you're given the point. This is called constructing a parallel line through a given point. So that point above the line is our given point. So it says you must go through this point and you must be parallel to the line already given to you. Okay, so the first thing that we're going to do, so this was given. All of this stuff was given. Now we're going to start our construction. The first step of our construction is to connect our points. So take your straight edge, step 1, connect the points. What have you created? I mean, it's just intersecting lines, right? We've got intersecting lines, there's 4 angles there. That's all we have so far. Okay, now we're not going to just take our straight edge and just be like, all right, that looks parallel, and draw it. No, we're going to perfectly draw parallel lines using our compass. The way that we're going to do this is by copying an angle. So we're going to take this angle right here, and we're going to copy it up here, and that's where our parallel lines are going to originate. So step 1, you put your needle at the intersection, you make an arc where you touch both lines, then you move your needle to that dot you made, and you make the same arc, identical twin arcs. So that's step 2. Make identical twin arcs. Make identical twin arcs, and it doesn't matter how big or small you open your compass. Okay, so far my needle went in this spot right here, and then my needle went in this spot right here. And I made identical twin arcs. I just put my needle, to make the second arc, I put my needle here, and I just curved my compass. Okay, second step of copying an angle, we've already learned copying an angle. The second step was always, see how this arc hits my lines twice, my rays? 1, 2, 1, 2. Well, that's where my needle and pencil go. Right here, I'm in bad shape. I am not ready to copy my angle. So I need to open up my compass a little bit. And I want my needle and pencil to pretty much be touching those 2 intersections. Needle, there we go. Mine's close enough. Mine's actually a little bit big. There we go. Okay, so now I specifically set my compass when I touched here and here. I set my compass. Now, where do I put my compass up here? I can't just put it somewhere on this arc. I have to put it at the only intersection I see. I have to twist it around, put it right here. My needle's going to go right here, and I'm going to make an arc just like that. If my needle was right here. Needle, pencil. That, you know how many points it takes to make a unique line? It takes 2 points. The one I had and the one I just created. So now the parallel line is the unique line that exists through these 2 points. So I connect it with my straight edge. Dun da da da. Parallel lines. How do I mark that they're parallel? I put an arrow on them. So now we have constructed parallel lines. In this construction, we actually relied upon these 2 angles right here. Do you remember what vocab word those 2 angles are? So, that angle and this angle, we copied an angle. What's the vocab word for those 2 angles? Good, corresponding. So now that we have parallel lines, and what we're about to discover only works for parallel lines. We constructed them. They're parallel for sure. They're confirmed. So now what I want you to do is look at those angles, and I have patty paper. If you have it too, that would be great. We're going to compare the measures of these angles by tracing and rotating our patty paper and seeing which ones are congruent. So I've got this angle that I started with, and it's congruent to that angle, so I'm going to go ahead and shade it. This one matches this one. Okay, what else? Does it match this one? No. That one's different. What about down here? Oh, yeah, definitely matches that angle. So he gets to be pink. This angle, does it match that one? No. Does it match that one? It's blurry, but you can tell no. And then does it match that one? Yes. So hopefully it'll unblurify itself. So everything that I just shaded in pink, those angles are congruent to each other. Okay, well what if I trace one of my other angles on my patty paper? One of these obtuse looking angles. That one is going to match that one, right? Vertical angles. Ooh, but it also perfectly matches that one. And perfect match for that one. So I could shade all of these angles and have some really pretty pink and teal flowers. So what we just discovered was literally 5 theorems. We just learned 5 theorems by doing that construction. Let me talk about one more thing first. We know that all the green is congruent to each other and all the pink is congruent to each other. How is the green related to the pink? What does the measure of the green and the measure of the pink, how are they related? Good, supplementary. So even this green one here and this pink one here, even though they're not a linear pair, they are, what do we say? They're definitely supplementary. So we realize that if the colors match, they're congruent, and if the colors are different, they're supplementary. So we just figured out 5 theorems. Like I said, let me show you. All of our theorems are going to start like this. If 2 lines are parallel, then let's go through each one. Look at your picture. If 2 lines are parallel, then find some alternate interior angles here. Alternate exterior. Boom, boom. Same color. So if 2 lines are parallel, then alternate exterior angles are, they go into the congruent column. Okay, let's try this one. Find some corresponding angles. So maybe this pink and this pink. Oh, they're the same color. If 2 lines are parallel, then corresponding angles are congruent. Okay, next one. Let's find some same side interior. Okay, the pink and the teal. The pink and the teal. Oh, those are different colors. So I don't put it in the congruent column. I put it in the supplementary column. Next one. If 2 lines are parallel and cut by a transversal, then same side exterior. Okay, teal, pink. Teal, pink, teal, pink. Oh, Those are definitely supplementary. If parallel lines are cut by a transversal, then, okay, let's find some alternate interior, sorry. Pink, 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 pink. Cool. So the 5 vocab words that we learned in the previous lesson fall into one of 2 categories. They're either congruent or supplementary. So all of the theorems, like I said, begin like this. If parallel lines are cut by a transversal, then corresponding angles are congruent. If same side exterior angles are cut by, or if parallel lines are cut by a transversal, then same side exterior angles are supplementary. So make sure you put this table in your notes, and underneath it you put if and only if, that's called a biconditional, if and only if parallel lines So these go into these categories if parallel lines are cut by a transversal. You know where linear pair and vertical angles go. I didn't want to put them up there because they don't fall under the category if and only if. Linear pair, those are supplementary all the time, every time. Vertical angles, those are congruent all the time, every time. So you don't need parallel lines for those to go into the congruent and the supplementary column. So those are left over from last unit. One of them is congruent and one of them is supplementary, but they don't go in those columns. Yep. So kind of what I'm saying is that here's what I'm saying. Angle 1 and angle 2 are alternate interior angles. Exterior, wow, I'm standing. That's easy to fix. They are alternate exterior angles, but they are not congruent. So to name them, the lines don't need to be parallel to name them, but for them to go into these categories, the lines have to be parallel. So I hope that makes sense. Okay. How can we remember which is which? Like, this is 5 terms. How can we remember which is which? Easiest thing ever. Yes. The ones that start with an S are supplementary. Same side supplementary, same side supplementary. If it doesn't start with an S, then they're congruent. Oh, no. You'll find out if the lines are parallel because the problem will just tell you. The construction tells you where parallel lines came from. So if you saw a question on a quiz or a test that said, what type of angles do you use to construct parallel lines? Your answer would be, oh, we used corresponding angles, boom, boom. We used corresponding angles to construct the parallel lines. But then we had all the other angle relationships when we were done. I want you to write this one postulate in your notes. I want you to write this in your notes. And then we're not going to write any of the other ones because all the other ones sound the same, except this part changes each time and this part changes each time. But I want you to have one of them in your notes, and then later at home you can write all 5 if you want. Same side interior angles postulate. If 2 parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. Okay, so the way your textbook does it is it takes one of the 5 things that we learned, one of them, and it calls it a postulate. A postulate is something that you kind of have to assume to be true, and then you can make theorems based off of that postulate being true. So someone, when they were trying to prove these angle relationships, you have to start with one of them, and they chose to start with same side interior. Not all textbooks do that. And then using that postulate, all the other theorems come after that. This isn't a big deal. I just want you to know about it because it's really mathy and nerdy. But, so the same side interior one is called a postulate. And then you use that postulate to prove all the other theorems. So all of these are called theorems, and this one's called a postulate. Miss Tanton will never be picky about that, though. If you call it the same side interior angle theorem, I don't mind at all. You can call them all theorems. But I wanted you to understand how mathematicians prove things. Sometimes they have to assume something is true or agree that something is true and use it to prove other things. Okay? Okay. So we're going to go from ultra nerdy and mathy to here's the most basic example I could give you. Here's the most simple of math that we can use based off of what we just learned. Okay. So when given a diagram like this that says solve for x, the first thing I want you to do is always state the vocab word. What kind of angles are those? Those are... That's what I want you to do first. State the vocab word. Then I want you to look and see if the lines are parallel. Are the lines parallel? You bet they are. How did we know? No, we didn't have to use a compass. We didn't have to make the lines. We just had to confirm that they're parallel. So, yes, so we've got same side exterior angles and we've got parallel lines. Now we can use the theorems, the two columns. Which column did same side exterior end up in? Supplementary. Same side, supplementary, same side, supplementary. So now I know exactly, these should have had degree signs. I know exactly what to do with these two expressions. I know that I add them to equal 180, and the rest is history. Remember, Miss Tanton cares less. I care less about you getting x equals 16, and I care more about the geometry. Why does x equal 16? And here's the theorem if I'm writing it shorthand notation. You just write if parallel, then same side exterior angles are supplementary. And that's the most abbreviated you're allowed to put the theorem. That's like super ultra abbreviated. So write that down in your notes. If we have parallel lines, then same side exterior angles are supplementary. This backs up the algebra that we did right there. Okay? Moving on. Try another one. Super simple, just getting you used to it. Okay, what did Ms. Tanton say? Step 1, identify the angles. Alternate interior angles. No, they're alternate interior. Not that, no. But I see where you're going with that, Fong. I see where you're going. Step 2, check to see if the lines are parallel. Check, parallel. Alternate interior angles landed in the congruent column. Very good. So congruent means they're equivalent. It means their measures are equal. So we can set them equal. 5x equals 60. X is 12. Let's write the theorem that supports our algebra. If two lines are parallel, cut by a transversal, blah, 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 then alternate interior angles are congruent. And that's the most that you can abbreviate that. Good, Franklin. This one, the directions say A is parallel to B and C is parallel to D. That was important. Had those instructions not been there, we couldn't solve this. The measure of angle 6 is 85 degrees. Find the measure of pretty much all the other angles. Let me show you what you can do if you have 16 angles and your lines are parallel. Let me show you a trick you can do. You can get out a marker or a highlighter, highlight the angle you're given, and then literally go diagonally and highlight all of the angles that are in that diagonal. See? Diagonal, 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 diagonal. Everything I just highlighted, those are congruent to each other. Everything I didn't highlight, those are the supplement of the ones that are highlighted. It's a neat trick that helps you literally solve for any angle quickly. All right, so let's look at the measure of angle 2. Angle 2 is highlighted. Angle 6 is highlighted. So they're literally the same measure, 85 degrees. Angle 4. Well, angle 4 is not highlighted, and angle 6 is highlighted. So angle 4 is not 85, it's the supplement of 85. 180 minus 85. 14. 14 is highlighted, 6 is highlighted, so 85. And we could go on and on. I could say, what's the measure of angle 11? And you would say, 85. What's the measure of angle 9? 95. What's the measure of angle 5? 95. You get what I'm saying. So that's what I call the circle trick. You circle all the angles on a diagonal, and that can easily, you can pick out which ones are congruent and which ones are supplementary. All right, I'll give you a minute to copy this diagram down in your notes. I would solve for y first, and then I would solve for x. Reminder, when the problem tells you GH is parallel to IJ, you go and add parallel markings to the picture yourself, but you never add them without being told that they're parallel. So what I recommend on problems like this, some students have trouble seeing the parallel lines in the transversal, and sometimes in problems like this, the transversal can be different lines at different times. So that rhymes, different lines at different times. So I like to highlight my parallel lines and start by finding a transversal. So parallel lines, transversal. Then I like to look at some angle relationships. How is this angle related to this angle? What's the vocab word? Corresponding angles. Very good. We know if parallel lines are cut by a transversal, corresponding angles, that doesn't start with an S, so they're congruent. So I don't have to do any more work. I'm done. Angle Y is 122. Now angle X, there's a few ways to get angle X. I'm going to use the way that needs a theorem for today, but there was a way to get it that you already knew how to do. So I'm going to try to use a theorem from today, but I'm going to need to use a theorem from middle school first. How many degrees are in a triangle? How many degrees? So you have to use some prior knowledge. It's called the triangle sum theorem. There are 180 degrees in a triangle. So if you use this triangle and you found this missing angle, which you definitely did not have to solve it this way, I just want you to be able to spot the vocab words. Then you've got your parallel lines, and you have a new transversal. This becomes a transversal. High, line high is a transversal now. What are these angles called? Alternate interior angles, AIA. That doesn't start with an S, so those are congruent, making X 40 degrees. I realize you could have solved it using the line, 180, but I wanted to show you alternate interior. Okay, next example. When you know X and Y, you may type it in the private chat. Okay, let's look at this. Remember, to employ the theorems we learned today, you must have parallel lines. The only set of lines that are parallel are these right here. So you need to extend them if this helps you see them better. So right now we're going to work on this transversal. This is our transversal, and those are our parallel lines. What's the vocab word for these two angles? We're not even looking at the other two angles. Don't even look at them. They're not there. Ignore them. If you can't see them, they can't see you. Okay, so those are same side interior angles. Same side supplementary, same side supplementary. So we know they add up to 180. So X equals 18? Or was it equal? No, 28. 28. X equals 28. Those two angles that I circle actually have nothing to do with the other two. You don't use the 5x and the 115 together. They have nothing to do with each other. So now I can start over, and you've got parallel lines and a transversal. These are also same side interior angles, which means they're supplementary. 115 plus 74 minus y equals 180. 189 minus y equals 180. Can you just tell what it equals? Y is 9. Here's what students do on accident, and I want you to see this very clearly. Sometimes they'll use the wrong set of lines that are not parallel, and they'll think that they can use the same side interior angle theorem on those two angles. Those two angles are, I agree, they are same side interior angles, but the theorem does not exist because those two lines, this line and this line, are not parallel. So you need to be careful when you're using your theorems. Has to be on parallel lines. Just for fun, I'm going to show you this proof, and if you're watching the recorded lesson, you can stop watching now, or if you're really nerdy and love to go deeper in math, here, this is for you, this proof, okay? We're going to start doing proofs soon enough anyway, so you might as well see more of them. We're going to prove the alternate interior angles theorem. We already know it's true. We proved it with patty paper, although it's called a patty paper proof. It is. But now we're going to prove it with a formal two-column proof. What are we given? We're given that P is parallel to Q. So on number 1, the reason that P is parallel to Q was that it was given to us. So that's the answer for number 1. We need to prove, this is the end game. This is our end game. Prove that the measure of angle 3 equals the measure of angle 5. Prove that alternate interior angles are congruent. So the first thing we want to do, angle 3 and angle 6 are supplementary. Why are they supplementary? Remember how I said that one postulate was going to help prove all of those theorems from earlier in the lesson? Why are they supplementary? Because of the same side interior angle postulate. We wrote that down in our notes. You wrote it word for word in your notes. That's why they're supplementary. Number 3. The measure of angle 3 plus the measure of angle 6 equals 180. Why? Why does 3 plus 6 equal 180? That's what you always ask yourself. Well, because of the definition of supplementary. That was from last unit. That's why they add up to 180, because supplementary means something. It's a vocab word. It has a definition. Okay. 5 and 6 are a linear pair. So now they're starting a new string of knowledge. They're moving on. They're saying, hey, if you give me this picture, I can tell you that 5 and 6 are a linear pair. Why are they a linear pair? Well, the definition of what a linear pair is. Definition of linear pair. They're two angles that are adjacent and supplementary. Now, after they say they're a linear pair, then they say that they're supplementary. So in number 4, that was definition of linear pair. Now we're actually saying they're supplementary. That's the LPT. That's the linear pair theorem. That's why. Okay, so therefore, 5 and 6 add up to 180. You can reuse something in a proof. Definition of supplementary. We just said they're supplementary, and then we say that they add up to 180. That's the definition of supplementary. Okay, this is the only one that's weird, is number 7. So what they did was they took these two, and they traded places. And some people call that the transitive property, and some people call that substitution. So I'm going to put that it's the transitive property of equality, and we'll talk about that later. It's from algebra. That property says if A equals B and B equals C, then A equals C, and that's kind of what we did there. If these two angles equal 180 and these two angles equal 180, well then by golly, they equal each other. And the final thing that we do is subtract angle 6 from both sides, and we're left with 3 is equal to 5. How did we get rid of the measure of angle 6? We use the subtraction property. It is an algebraic property. So anyways, that's a formal proof in a nutshell. That is us going step by step, going from all we were given was this, and we made it to the alternate interior angle theorem, saying 3 is congruent to 5, using only the same side interior angle postulate. Bye!